All right. So who all we have in the class? We have Thanu, Gitesh, Hiranya, Dikshita, and Sanvita. Let me do one thing. Let me send a reminder to everybody that class has already started. So, where are the kids? Level 2. Class has started. Alright, so here's Myra. So I will request everybody to keep their videos on so that I don't feel like talking to robots or don't feel like myself being a robot. Alright. Yeah. Good to see you guys. Hello Hiranya. So welcome to the class Hiranya. I mean, this is your first class, so very happy to have you in the class. And as I keep saying, all the kids here in this class are my own kids. That's how I treat everybody, okay? So what does it mean is, when you learn something, when I teach something, I might not be the best teacher. If I teach something which is not clear, don't hesitate. Just ask questions. If there's something that you're not able to follow or understand, there's nothing wrong in asking questions, okay? So just feel comfortable and ask questions. And as I said, you all are my kids. So Myra is actually my daughter, and you all are equivalent to Myra for me. So happy to have you all in the class. Let me start recording it. Okay, I have already started recording. Now, I see some kids are still missing and they would join as we start. But let me quickly tell you guys that, see, this class is for level 2. Level 2 meaning all the kids from 6th grade till 8th grade. So what I'm doing is, I have put the syllabus of each and every grade from 6th till 8th, and that I have made as a syllabus for level 2. And we have done one iteration of that so far. Now we are starting the second iteration, meaning all the concepts we are starting from today, and in next 4 to 5 months we will cover it one more round, okay? We might be able to cover it all, we might miss some of the concepts, but you guys can always reach out to me and ask me if there is something that is not clear yet, okay? So leverage this platform, leverage this class to ask as many questions, as many valid questions, unlike what some kids do when they ask questions which are not relevant. And some of you know what I'm talking about. So, okay, now, okay, when you have come to the class has already started, no parallel talks are anticipated. Now, let's look at what all we are going to cover in the class today. So, our topic for today is going to be understanding ratios, fractions, percentages, then ratio, fractions and decimals. Then we'll talk about ratios in tape diagrams, equivalent ratios, and then solving some word problems around that. Okay, so this is the first unit that we are starting with, which is going to be a repeat of what we have learned before, but this is our starting point. Any questions before I get going? No? Okay, so let me do a quick roll call just to make sure who all we have right now in the class. We have Dikshita, Gitesh, then Hiranya, Lakshita, Myra, Sanvita, Bhuvan, Vivan, Thanu, and here in the classroom we have Advik and Arav. Alright, so some kids seem to be missing, but that's okay. They will anyways join, and whoever misses the class, so Hiranya, this is an information for you. Whatever we do in the class, it's only me and the board that is getting recorded, and that recording goes onto YouTube only for you guys to watch and revise. So when you are in the class, you don't have to stress out or worry about taking notes, because you just focus on learning the concepts or following the concepts, and you can always revise it by watching the video whenever you miss something. Yes?
Why don't you just put it on like the group chat?
No. The group chat I put, right? I always put the link of the video on group chat. So let's start. What do we mean by ratios and
I was going to tell something.
Mhm.
The second page of the homework we couldn't read, so I did it. So
What is that?
the second page of the homework was blurred.
Okay.
So I just got it.
That's fine. We'll come back to this topic again one more time. So as long as you have understood, it should be fine. So let's start. What is ratio and fraction and percentages and decimals? Hands down. If you keep raising your hand for every word I utter, I will not let you ask questions or not even let you answer questions. Just be mindful and respectful of everybody's time. Okay? You're not the only child in the class. We have to make sure that we follow a pattern. Okay? Now coming back to this one. So ratio, percentages, decimals and fractions. Anybody in the class who is not clear about what are all these? What do you mean by ratio? What do you mean by fraction? What do you mean by decimals or percentages? The concept level. Anybody who is not clear? Everybody is clear? Now let's look at some classic examples. When you say ratio, it sounds okay. Ratio is ratio. Now let me give you an English definition of it. When you compare two numbers against each other, right? If you compare 2 and 5, let's say, if you compare my weight and your weight, okay, in kilograms, or let's say in pounds, if I look at one of the kids' weight and my weight, the teacher's weight, I'll probably be like 170 pounds and you guys will be somewhere around 50 pounds. This is when you're comparing the numbers, comparing two values, ratios give you a way to do that in the mathematical way. If I say my weight is very high, your weight is very low, doesn't matter. It's a very subjective statement. When I say my weight to a kid's weight as a ratio, that is when you see that okay, my weight is almost like 3 times the weight of a child in the class. If I say your age to my age ratio, you guys are like 10, 11, 12, 13, and look at this, right? Your age is almost 1/5 of my age. Yeah. I mean, I have not disclosed my actual age, but it is pretty close, pretty close. So what I'm saying is, when you're comparing numbers, that is when ratio helps you relate it in a conceptual way. Now, if I look at, let's say, again, don't get offended, I'm saying, let's say Dikshita's age versus Hiranya's age. You'll see they are the same ratio, 1:1. Let's say Myra is, let's say, 1 year younger than one of you. I don't know who. Okay? Then Myra's age to second kid's age is close to 1:1, or maybe 90:100, or maybe 95:100. Very close, right? So ratio in absolute terms, if you look at it, ratio is nothing but a way to compare two numbers. Now, how do you represent that? You will say, let's say the amount of money I have spent for buying rice versus amount of money I have spent for buying, let's say, flour. Okay, so let's say I spent $15 for buying rice and spent $12 for buying flour. Okay, then money spent between rice and flour is in 15:12 ratio. This is the ratio. So basically you are comparing this versus this. And this is how you represent it. Now, there is another way you can represent it. You can represent flour in terms of rice or rice in terms of flour. You can say 15:12. 15/12. This is the money spent in the fraction form where you are keeping your rice as your base and this is being compared. Okay, so here you'll say rice is probably, you have spent 1.3 times more on rice versus flour. Or you can say you have spent 80% less. So on flour compared to rice. So basically, here these are two representations when you talk about ratio versus fractions. Both are same thing. You can look at this as a comparison and you can look at this as a mathematical calculation. Is it making sense so far? Is everybody with me? Ratio is more of a way to compare, and fraction, which is again derived from this one, which gives you a more mathematical answer to that comparison that you do. So this is the ratio and fraction difference. Any questions so far before I move on?
Does it matter what side you use in the ratio?
Yes, it does. My age to your age ratio versus your age to my age ratio is going to be way too different. So if you look at it this way, I'm saying, let's say I'm putting, this is my age, or I'll say teacher's age. Teacher's age, and this is Araf's age. The teacher is on the verge of retirement. Araf had just started middle school. Yep, I'm pretty close, might be a little far, but it's okay.
That's the same age.
Yeah. Now, teachers to RF ratio. To RF's ratio, RF's age ratio will be 48:12. You can represent this in the fraction form as 48/12. RF's to teacher ratio will be 12:48. And you can represent this in the fraction like this. See if you see any similarity, any closeness among the values that you are going to get. So now, why when I'm saying that I'm old? I'm very much a toddler, isn't it?
Because you're
I have a scale to measure that, right? We always measure against a scale. Now, somebody, before I was born, somebody decided or defined that, okay, 365 days is 1 year. So how many times I have clocked 65 days, that is adding to my age every year, right? Every time I clock 365 days, that adds one more year to my age. So I have probably clocked 365 days 48 times. That is how I am 48 years old. So what am I saying? This is your measuring scale. Everything that you measure against a unit. If you are measuring age, you measure against years. If you are measuring distance, you measure against mile. Mile, again, somebody has defined how much a mile is. A mile is made of certain yards, it's made of certain feet, right? And that is how that becomes your scale. So anything that you measure, you always have a base, a reference frame against which you measure. So here, when you say RF to teacher's age ratio, you are taking RF as a base and then comparing his teacher's age against that. When I am saying teacher's age to RF ratio, I am taking teacher's age as the base and then comparing RF's age against that. Yeah? So, in a nutshell, when you are talking about any number, any value, you are always comparing it against a base. There's nothing that exists in the world without a reference. If I am trying to even use this board is placed against a wall. Imagine if this wall was not there, the board never existed. If I'm trying to write on the board, I'm writing on this corner versus this corner versus this corner is again with a reference to something. So, anything that you measure, you have a scale. If I say that I am 5 feet 7 inches tall, I'm measuring myself against a scale that is defined. This much is 1 inches and 12 of that becomes 1 foot. And then I'm using that scale to measure how tall or how short I am. Right? So you always have a scale. So ratio is again same thing. Here you're not measuring anything against a unit, you're measuring a number against a number. That is where you compare. So be it a ratio, be it a fraction, these are different ways to compare a number against another number. Is that a fair statement in terms of English? We have not done any math so far. Everybody? Now look at what are those comparison scales or methodologies or the tools that we use for comparing. Now let's stick to my and Arif's age for next 5 minutes. So Arif's age is 12 years, teacher's age is 48 years. Now I can say Arif's age to teacher's age ratio. It will be 12 is to 48. Arif's age and teacher's age can be represented in form of fraction also. Now, next thing you can do is, if you have a fraction, can you convert this to a decimal also? It becomes 0.25. Yeah? Or you can convert this into a percentage also. And then you can read it. Here you say R's to teacher's age is in the ratio of 12 is to 48. R's age to teacher's age is 12 by 48. R's age to teacher's age is equal to 0.25. And you can also say R's age is 25% of teacher's age. So there are 4 different ways you can compare these two numbers. So that is what we are talking about: ratio, fraction, decimal and percentage. Any questions so far? Now who all are strict vegetarian in this class? Who don't even talk about chicken? Anybody? You are vegetarian? Okay. No, so I'm not trying to motivate anybody to eat chicken. If you eat, wonderful. If you don't eat, don't worry. It's perfectly fine. Now, there's a chicken. There's one form of chicken that we always deal with.
Chicken curry.
Huh?
Chicken curry.
When I'm talking, let me talk. Let me finish. Probably once I finish, then you'll get some conclusive view out of it. If I say 6 by 13, convert this to decimal. Now, so you can imagine that, okay, we're talking about two numbers which is the ratio of 6 is to 13. I'm saying convert this to decimal. And that is where chicken comes into play. I mean, mostly I teach this to much younger kids, but since there's some interesting element to it, that's what I'm teaching you guys. If you divide 6 by 13, who all knows how much it will be?
Approximately.
No, approximately. Do it and tell me.
I didn't know my mind. Because
I don't care about mine. I don't really care, because you go for an exam and teachers give you 10 questions and you say, okay, in my mind this is the answer. That doesn't go anywhere. 6 by 13. And I'll not give you guys more than a minute, okay? This is a very easy one. Yes, B1.
2.166.
2.16?
Yeah, I mean round it up. This round.
6 by 13. Are you sure? Yeah, Dikshita.
0.46.
Okay.
Yeah. I changed my answer. Sorry, I did 13 over 6.
Yeah. Yes,
Yeah,
Sanvita.
0.46.
Yes, Sanvita.
I got the same thing.
Now I'll tell you why I keep talking about chicken, right? Yeah, Gitesh.
0.461 in was on.
Okay. Now look at Myra. What was your answer?
I got the same.
You got the same. Okay. Now let's look at how interesting is chicken here. Again, I'm not trying to motivate anybody to eat chicken. If you don't eat chicken, that's fine. Now let's look at it. 6 by 13. That means I'm trying to divide 6 by 13. That is what my goal is. And how do I divide 6 by 13? 6 is smaller than 13. No matter how many times I do the table of 13, I will never get 6. That is when decimal is my chicken, which lays one egg at a time. Okay? Decimal is my chicken which lays one egg at a time.
You taught us before.
Right, I'm repeating myself. This is now we are going to repeat the whole syllabus. Don't worry about it. So decimal is a chicken which lays one egg at a time. So as soon as I put a decimal, I got 60. Now I have 60, which is more than 13. I can think of dividing.
4.
13 times 4 is 52.
8.
I got 8. 8 is again smaller than 13, but I have a chicken which keeps laying one egg at a time. So this decimal laid one more egg. I got 80. 13 6 is 78. Yeah, 13 6 is 78. I got 2. But my chicken keeps laying one egg at a time. 13 1 is 13. 13 7. My chicken keeps laying one egg at a time. 13 5 is 65. And it goes on. It's not stopping. So why I was saying chicken, I've seen when kids do this division, right, I've seen they get stuck at some point and then they leave it. I'm saying that no, it's no big deal. You're simply doing division, and remember this, as soon as you put a decimal, that keeps laying one egg at a time. So I call the decimal as a chicken, which has a habit of laying one egg at a time. At every step it will lay one egg.
It's an irrational number.
Yeah. Yes, Gitesh.
If the division ends, what happens?
What is that?
Chicken. No. What if what if the division ends?
So-
Does the chicken?
No, then chicken takes a break. See, every day when I go to work, right, I have to work for 8 hours. After I work for 8 hours, I take a break, right? I'm done for that day's work. That is when I come home. So chicken's work gets done as soon as everything becomes 0. If I'm doing 1 by 8, same thing I will do, 1 8. The chicken lays one egg, 8 1 is 8, 2 remaining, chicken lays one more egg, 8 2 is 16, 4 remaining, chicken lays one more egg, 8 5 is 40. This is the time when chicken takes a break.
Wait, you drive to work?
Yeah.
That's
Yep.
in the office.
Okay. So that is out of syllabus, we will take it offline. Now coming back to this one. So basically, this was third part, right? We saw how do we compare two numbers, and then we repeated that as a ratio. If I am comparing these two numbers, this is represented in the form of a ratio. Then converting this to a fraction. This is same as this thing. You can repeat this form, and from that you can convert this to a decimal. 6 by 13 is a fraction. That means 6 is divided by 13, and you get a decimal. So from that you get a decimal. And this is where chicken and egg thing comes into the picture. Now, whole thing that we have done so far is nothing but relating two numbers, one number against another number. Okay, be it ratio, be it fraction, be it converting to decimal. Right? When we converted 6 by 13, it became this decimal. How do you relate it? You can say 0.4165, meaning one number is this times of the second number, meaning the numerator is this many times of this number. Imagine this, if I say 48, my age versus Arab's age, when you divide this, it becomes 4, right? How do you read it? 4 is 4, so my age is 4 times of this age.
4 groups of 12?
hold it there. Talk when you are adding value. Right now, let me complete first. Again, 6 is this many times of this value. 48 is this many times of this value. That is how you will read it. So this is just the interpretation part. Is everybody with me so far? Okay. Now, so we looked at what is ratio, what is fraction, how do you convert things into decimal. Now,
A percentage.
next thing is percentage. And again, you guys might think that we are talking about all basic stupid stuff which is very kiddish, very much kiddish in nature, but this is your building block. Now look at this. Same 6 by 13. When you divided, you got 0.4615 and it was going on. Now, so the way we read this was 6 is this many times of this value. Now, there is another reading where you will say 6 is some percentage of this value. Numerator is certain percentage of this value. How do you get that? Put that number and multiply that by 100. Whatever you get, that will be your percentage. So these are 4 ways to compare numbers. When you are talking about this particular unit or whatever we wanted to cover today, we are talking about how do you compare numbers and what are the different ways of comparison and interpretation of that number. So first thing, when you look at ratio, it just is absolute comparison. When you look at the fraction, this says this number is divided by this number. When you look at the decimal, you found that okay, fine. 6 is this many times of this value. That is how you will read it. Or let's say if I say 5 by 8 equal to let's say 0.68. I am saying 5 is this many times of this value. Eventually 5 is this many times of this value. See, that is what it will translate into. So these are different ways of interpreting numbers and the comparison. Any questions so far before I move on?
Are we learning compounded of that simple with that percentage in the later months?
No. Don't disrupt the flow of the class. I will tell you what we are learning and we'll go step by step.
I think it's a fluid issues now.
Wait,
Okay.
maybe also-
There is no debate going on right now. It is a one-way flow of traffic.
Yeah, I know.
It's a one-way flow of traffic. Okay? You will not be able to teach anything. It's only me teaching right now. Okay? Alright. So now we looked at what is going on?
You just have to pencil around.
Not actually.
There are more accidents that can happen. Right? I can also lead to an accident. I will call up daddy and say, don't have to be violent in the class. That's why, see, when you are studying, your full energy has to go into only that thing. Don't go all over the places. Are you okay? See, don't do anything of that sort. Accident cannot be an excuse for doing something wrong. Eyes are precious. Imagine if you were just making a mistake by a few more centimeters, people can lose their eyes. You know that? And once somebody loses the eyes, they cannot get it back. So control your body movement, control your emotions. That is the only thing that you will learn apart from studies when you grow up. Okay? Don't do anything like that. Alright, so coming back to this one. So we talked about ratio. So tomorrow if somebody says, okay, price of blueberry and price of cherries are in this ratio. Meaning you can get 1 pound of blueberry for $5 and 1 pound of cherries for $8. They are in this ratio. Okay? Now, You can also say this is the ratio of the price. Now, this is another term that you will come across, that is equivalent ratio. What do you mean by that? You will not get a chance to answer. Today you made a big mistake. Yeah.
Ratios that are equivalent.
I mean, that's the little meaning. I said equivalent ratio, meaning ratios that are equivalent. Yeah. How do you repeat that?
Ratios that are like equal but like different numbers.
Okay. Let me see what Myra, Lochita, Thanu want to share. Vibhuvan. What do you mean by equivalent ratio? Now we know what is ratio, but what do you mean by equivalent ratio? Yeah, Dikshita.
Maybe like they should be like going to like the same table where that can be simplified.
Yeah. So if I say another way of mentioning equivalent ratio is, I can have two different ratios like 1/2, 2/4, 4/8, but their absolute value is same in decimals. Yeah. When you have different looking ratios, but the absolute value is same.
So it's like ratios but in a more simplified way.
Any which way, it could be simplified, it could be complicated also. If I have 3/6, I can simplify it to become 1/2 and I can complicate it to become 300/600. But the underlying value of these are the same. Yeah? So, now look at it this way. Look at this guy, 1/2. When you convert this to decimal using a chicken egg formula, it gives you 0.5. 2/4 will also give you 0.5. 4/2 will also give you 0.5. The absolute value of ratios when they are same, even if the numerator different and denominator combinations are different, and the absolute value in the decimal is the same, they are called equivalent ratios. Are you guys with me? Hiranya, are you able to follow me better? Yeah? I know everybody else in the class, they have been getting tortured by me for some time, so they know what I say. It's your first class, so that's what I'm asking. Alright. Now, question to you. If I say, find out 3 equivalent ratio of 2/6, how will you find it?
We will first have to write all.
No, you don't have to rush. Take 30 seconds if it is needed. I'm saying, find out 3 equivalent ratios of 2/6. I'll come to everybody. I'll give that problem to everybody. I'm just checking how much you guys are thinking. Okay. If I say find out 100 equivalent ratios of 2/6, how much time you will take? Any guesstimate? 100 equivalent ratios. Yeah, Tanu.
I think it'll take 5 minutes.
Okay. How about you, Pranav? How much time will it take for you?
5 minutes.
5 minutes. Okay. Yeah.
7-ish minutes.
5 to 7 minutes. Okay. Now, why I'm asking that question? Finding out equivalent ratio. Okay. Aaron, you found your answer? What are those?
4/12, 6/18, and 8/24.
Okay. Now, what I'm saying is, observe these numbers. 1/2, 2/4, 4/8. Everything gave us 0.5. Now I'm saying, find out equivalent ratio of 2/6. Okay. Let's do a little bit of fun activity so that we can relate it this way. If somebody says, find out equivalent ratio of 14 3/9, that is when it will get even more interesting, right? And that is where some of the punchlines of mine might help you. I'll tell you what are those punchlines. Hiranya is the first interaction or first encounter with this old teacher, so I'll tell you what are those punchlines. Now, first of all, look at this 2/6. There's one thing we do in the class that is called tic-tac-toe. Okay? And the tic-tac-toe is nothing but, it is a complementary thing that comes with our math. 2 I can write as 2 into 1 and 6 I can write as 3 into 2. And this is where the tic-tac-toe happens. This 2 and this 2 is gone. It becomes 1 by 3. And now tic-tac-toe meaning, see what do I do by tic-tac-toe, right? I'm knocking off the common things. Meaning when you have something in the numerator and denominator both, you can knock them off any time. I can write 2 by 6 as 1 by 3 also because I could knock off the common things between the numerator and denominator. I can do reverse tic-tac-toe also when I have to find out equivalent ratio. Meaning 2 by 6, if I can multiply everything by, I can multiply the numerator and denominator both by 3 as well. Because I know that I can do tic-tac-toe whenever I feel like. I can do multiply with same number and divide by same number again. That also will give me the same value because I can do tic-tac-toe any time. So tic-tac-toe is nothing but, it tells us that if you have a common factor in the numerator and denominator, you can knock it off any time. It doesn't change the value. So this is reverse tic-tac-toe. When you have to find out equivalent ratio, you have some number and you have to find out the equivalent ratio of that. You will do reverse tic-tac-toe, meaning you can just go on multiplying that and dividing that by the same number as many times you want. I said, can you find 100 equivalent ratio? Yes, you can multiply it by 2, you can multiply and divide by 2, multiply and divide by 3, you can multiply and divide by 4, and you can just simply go on. Does it make sense? Vivan, are you with me? Yeah? Vivan, are you with me? So,
Yeah.
so far I was teaching you guys tic-tac-toe as a means for simplifying your calculation. When it comes to equivalent ratio, you will do reverse tic-tac-toe. Meaning you will go on multiplying and dividing by the same number if you have to find out something. Yeah? So now the second punchline of mine that you guys have heard so many times except Hiranya, that is fraction is my best friend.
But that decimals were your best friend.
Huh?
I thought decimals was your best friend.
No, decimals were never my best friend. Fractions are always my best friend. Meaning, whenever I'm dealing with a situation which is little tricky, I will try converting that to fractions. Like the chicken came to our rescue when we were trying to divide a smaller number with a bigger number. Chicken came to our rescue. Same way my best friend comes to my rescue when I'm dealing with numbers when they are in a little complicated form. Here this is in the mixed form. So first thing I will do with this guy is, if I have to find out the equivalent ratio of this guy, my best friend is fraction, who comes to help me. So I'll convert this to a fraction first. How much that will be? Who doesn't know how to convert this to a mixed number? Who doesn't know how to convert a mixed number to a improper fraction? How much that will be? 14 3 by 9. I know you guys have not been practicing table of 14.
I'm done.
Yeah,
129.
yeah, Dikshita. Tell me how much it will be.
129 by 9.
Okay, so 14 9 is 126 plus 3. 14 times 9 plus 3 by this. So 14 9 is 126 plus 3 129 by 9. And now we know we have to find out certain number of equivalent ratios. I can just go on multiplying and dividing by the numbers. I can choose any number that I love, like, hate, dislike, agree, disagree. And as many numbers I need. Yeah, I'll just multiply and divide by the same number. Yeah. So this is Dikshita.
When we times it, do we have to multiply by the same number, or can we divide, multiply by 7 over 6 or 7. Should we have to do like 7 or 7?
7 or 7. It has to be the same number. Because if you multiply and divide by different numbers, the value changes. See, the intent here is this. Now, let me give you a very lame example here. Let's say if you guys learn to solve problem in a certain way. If I find another way, say, okay, no. In India, when I was small, I learned a different method. If I give you that method also gives you the same answer compared to the answer that you get using your method, then you're fine. You solve problems in a certain way and get an answer which is correct, and then I give you another alternate method where the answer is different, then my approach is not right. So same way here, when you are looking at, you have a number already, 129 by 9. What did I say? When you are talking about equivalent ratios, your decimal value, your absolute value will not change. So 129 by 9, let me give you guys an example that you'll be able to relate better. Let's say, I pick a smaller number, okay? If I say 1 by 2, okay? 1 by 2 gives me what? Actual value is 0.5 in decimals. Now, I'm trying to find out equivalent ratios. I will do multiply and divide by 2. That gives me 2 by 4. 2 by 4, when I do 2 by 4, chicken comes to my rescue, makes it 20, 4 5 are 20. Done. My answer is 0.5. It's just same. Now, life becomes more complicated if I did a bit of an adventure. I multiplied by 2 and divided by 3. What it became? It became 2 by 6. Now look at the absolute value of this guy. You're trying to divide 2 by 6. The chicken comes to your rescue, makes it 20, 6 3 is 18. 2 is remainder. Chicken gives one more egg. 6 3 is 18. 2 remainder. Chicken gives one more egg. 6 3 is 18. And that just goes on. But now you look at the absolute value. 0.33, 0.5. By multiplying and dividing by different number, what did we do? We changed the absolute value. So my method is giving you wrong answer. So I should not be forcing you to use my method. I mean, that was just an analogous example, okay? So what it means is, whenever you have a fraction or any number, you can multiply and divide by same number. And that number can be as small as 0, as big as millions or billions. But your number which is getting multiplied and divided, which is multiplying the numerator and the denominator, that has to be same. Otherwise, you are changing your value. And changing your value will not be liked by the teacher. Yep. Now let's look at, okay, we still have 15 more minutes. So now let's look at some concepts around this one. See, ratio, decimal, percentage, fraction, all this you guys know already. You are knowing it. So I'm literally wasting your time. Yeah? Sometimes teacher wastes your time also. But the concepts, if you are clear about it, you will probably come across questions which are straightforward, and there will be questions where you'll have to apply your understanding for solving word problems. So now let's look at a word problem and then try solving it. Now I'm saying there are 12 girls and 8 boys in a classroom. In a classroom. 3 girls joined the class. 3 more girls. Okay? Girls joined the class. How many more boys need to join so that the ratio, boy to girl ratio remains the same? Yeah? Yes, Gitesh.
3.
No, don't rush. Now you have learned some concept. Again, let me repeat it. 12 girls were in the class. 12 girls and 8 boys were in the class. 3 more girls joined. How many more boys need to join so that the boys to girl ratio remains the same? Yep.
2.
Okay, I got one answer. Let me repeat the question, which aligns with my method, which says, see, every time I have a new child in the class, I get tempted to talk about trans.
Yes, he's trying. No,
So-
not our turn.
So,
No,
okay, that's fine. So, T stands for trust, meaning you always trust yourself. If there's any problem that you are solving, that is you. That can be solved, that is you. Read stands for, R stands for read. Read and read. Any problem that you're trying to solve, read the question enough. A stands for analyze or analysis. And then N comes as the last point, which stands for Nike. Nike's slogan is just do it. What I'm trying to say is always trust yourself, never be afraid of a question. Read the question enough, analyze or think how you are going to do it, and then you try doing it. That's the message. Yes, Samita.
2 more boys.
2 more boys. Yes. So for everybody in the class.
but
Yeah.
2 more boys.
2 more boys. Okay. So everybody gave me the answer that we need 2 more boys. Now, how was it relevant? How was this question relevant? Let me read this question one more time. There were 12 girls and 8 boys in the classroom. 3 more girls joined. How many more boys need to join so that the ratio remains the same? So essentially here, if you look at it, whatever I said, if you apply this method, reading, right? I talked about the question so many times that everybody remembers what the question was. Then I'm analyzing it and then I will do it. So message to everybody is, don't rush to solve a problem. So Gitesh, you said 3. That was because you did not follow track. You went to N as the first step. You did not analyze, you did not read the question clearly. And again, I'm not trying to put you on the spot or anybody on the spot. Here, you guys are like my own kids. I mean, I'm not trying to make anybody feel bad. My message to you guys is, make that a habit. Every problem that you come across, read it enough, then analyze, put your thoughts together, then you try solving it. You'll not go wrong. Now let's do it. 12 girls and 8 boys. I mean, if I were you, this is how I will approach this problem. So there are 12 girls and 8 boys. So earlier the ratio was 12:8. If I represent that in fraction, it is 12/8. Now 3 more girls joined. So 12 plus 3, this became the number of girls. Now how many boys will need to join? So earlier they had 8 boys. I don't know how many need to join. Probably X. I don't know. What is the value of X right now? So 12/8 was my earlier ratio in fraction form. Now my new ratio is 15/8 plus something. 8 plus something. Now look at this. 12/8 gives you how much? 12/8 gives you 1.5. Now 15 by something should give you 1.5, right? Let's say 15 by something is y. Let me not even say this. 15 by x. This is my new ratio, okay? So let me write x only so that you guys don't get confused. This was my earlier ratio. I want to make sure my ratio remains the same. Number of girls has changed to 15. I don't know what the number of boys has to be. My earlier, this thing was 1.5. So now with the new number of boys, the ratio has to remain the same. The decimal value should remain the same. So 15 by x has to remain as 1.5 only. I don't know what is the value of x right now. So 15 by x has to be 1.5. Now do whatever you want to do. So you move x to this side and bring this guy this side so that you get x on one side. So if I move x to that side, then this guy will come down. So 15 divided by 1.5. Right? Now 15 divided by 1.5. You know how to convert decimal to fraction. So this becomes 10. Decimal, in place of decimal you have a 1 and then you have 1 digit, so 1 zeros. So then this becomes 15 by 10. Now you can do tic-tac-toe also here. 15 and 15 gone. Total number of boys you need to have is 10. You already had 8. How many more you need to find? So 15 by, so this x has to be 10. So x has to be 10. 8 plus something has to be 10. Then you know it's 2. Yeah. So look at this thing. Did I do something complicated? Probably not. I just read this question, 12 girls to 8 boys. So, and we are talking about ratio, so this is my ratio. This is the fraction form. When I am talking about adding some more boys to get the same ratio many, my decimal value should not change. So this is 12 by 8 gives me 1.5. Now I have 15 girls. 15 girls by how many boys will give me 1.5? That is what we are trying to find out. Yeah. Did you guys follow what I did? Lochita, Hiranya, Sanvita, everybody? Pranav? Tanu? Everybody clear? Not clear. So, see again.
Yes, sir.
Yeah, beat ratio, beat fraction, beat percentage. In all the scenarios, your absolute value should not change. When you're talking about two ratios being same, you're essentially saying that my absolute value or the decimal value should not change. If you're talking in terms of percentage, you'll say, okay, my percentage will not change. That is how you relate ratios, percentages and fractions. Are you guys clear?
Yes,
Yeah?
sir. Yes, sir.
So,
Yes, sir.
now what we are going to do is, for this topic, obviously we'll learn a little more about it in the next class. So we have just touched the surface of this particular topic and we'll try covering this unit by tomorrow. And then you will see that in this particular unit, most of the things are going to be around word problems. And word problems, the silver bullet for the word problem is try. If you don't practice try, you will see that is only for you because you don't listen.
What about me? My phone.
I mean, if you say, then I have to add L for you also. So what I'm saying is, these concepts that we talked about, there's nothing complicated about it. Where it will come handy is when you have to deal with word problems. Word problems are not difficult. They are just made for getting you confused if you don't pay attention. So that is where this comes as a silver bullet for us. I'm saying you forget about T also. If you are in the class, you don't have the option of not trusting yourself, right? I mean, if you study a particular subject and if you think that no, I cannot do anything, then you better stop studying itself, right? So trust should be there now. Let's not talk about it even. How do you run? I know this is not the right spelling of run. It is ran. But that's still fine. I'm saying how you have to always make sure you read, analyze and then do it. As long as you make that as a practice, you will see your success rate gets better. Okay? And that is what we'll essentially do when it comes to word problem. Because in the word problem, this becomes your key for doing it right. When you read the question again and again, couple of times, you will see that it becomes much more easy to comprehend and then solve it. Yeah? So we'll talk about few more concepts in the class tomorrow and then I'll give you guys homework. And this time I'll make sure that I don't give you guys homework which is not a word problem. I mean, there'll be more of a word problem, less of a calculation problem so that you can practice that more and be ready to to deal with those word problems in a much more efficient way. Okay. I mean, so far in the first iteration when we were learning these concepts, we were focusing more on solving the mathematical problems. Now with we into the second iteration of it, it will be like 30-70 kind of a thing. 30% for solving regular mathematical problem and then more focus on word problem, because that is what you will encounter more, be it SAT, be it even your STAR test or your future tests that you will come across.
SAT.
Yeah, SAT is way too far for you guys, but I'm just getting you guys mentally ready for it.
Is it college or high school?
After high school,
What if
in the high school.
What if you get
Or,
if you get a hard one?
let me just quickly check. Anybody on the screen, if you had any doubt, anything that is complicated, cryptic or useless that we went through? No? Yes?
So I have a question.
Yes.
When I asked my parents, they said what's N?
What is?
And then trend.
And trad is the method we use for approaching a problem. Okay? So T stands for trusting yourself. That if there is anybody in the world who can solve a problem, that is me.
Give me outro.
And then R stands for reading, meaning when you have a question at hand, read it enough. Once, twice, 3, 4 times till you get tired. And you are confident that okay, you have extracted all information from the question. And then you start thinking, how will you approach? What all information I have? What formulas I know? What I can apply? How will I go step by step? So that is creating your blueprint. And then you come to N, which is N stands for Nike, which says just do it.
I love Nike.
So basically, I have just devised this method for you guys so that when you pick a problem, you trust yourself, read the question enough, analyze or make your plan, and then you do it. Otherwise, what happens? You take a question, you have not even read it enough, and you start solving it. You might go in a wrong direction, and then you might end up wasting a lot of time coming back to the original problem itself. So that's why it's a method given to you all based on the number of gray hairs I have developed so far to go in a certain pattern so that you don't waste time, because every minute that you waste or save is going to play a very important role with respect to how will you do in the exam, where you are hard pressed for time. Yeah. I know it was a long speech, but I hope I made some sense out of it.
At 6 o'clock.
Yep. All right. Have fun. I'll let you guys go and we'll resume tomorrow, same time. All right. Yep. Bye bye. Take care. Bye bye. Bye bye. Bye bye.
Who is such a high-pitched voice?
Yeah.
Bye, sir.
Bye bye. Bye bye.
Who is in such a high-pitched voice?
That is out of syllabus. I will not care about it.
Okay, but who was it?